Hey guys, so we're back with another experiment, and for this experiment, just please make sure we have adult supervision again. I guess all of these are probably going to involve adult supervision, and we're just going to need a couple of things. So the few things that we're going to need is, I'm going to be using matches, and that's why we need the adult supervision. Some sort of funnel, a regular large funnel would work if you have that at home, but I'm actually using this cute little small one, so if you can use a smaller one, the better. And we're going to be using balloons, and make sure the balloons are big enough. These are the medium to large size balloons and not the small ones because they'd be tough to work with. And we're going to be doing this with a flame. All you need is just a candle. As you can see, I have my candle melted in place on a plate. It doesn't need to be the case. You just need some sort of candle that's stationary, so any old candle would work. The larger the flame, the better. So what we're going to do is we're going to try to do kind of two different tests. And the first test we're going to do is just fill in a balloon with air. We're going to fill this guy up, and we're going to put this over a flame afterwards. So let me first light the flame with the match. And, again, adult supervision. And don't burn yourself. Alright. Like so. And you're just going to let that flame sit for a minute or so. And let's blow this up with air. I don't know if you've ever done this before, but the reaction's quite large. Let's fill it up right now. Alright, that's good. And we're just going to form a knot on it. Alright, I just learned how to properly form a knot in a balloon today, so give me a minute, please. Alright. I'm 22 now, and I just figured out how to correctly form a balloon knot. Alright. And I'm going to put it over the flame. Let's see what happens, alright? You just got to be really, really careful with it. Alright, exploded. That actually was cool. It bounced off the roof, the ceiling. So maybe let's talk about why it exploded first. So when you blow into a balloon, you're putting air, your breath, into the balloon, and then you close it. So the only thing that is in that balloon is the air from your lungs and the material of the balloon itself. So when you put that over a candle, it has a flame that has heat. That's why it's hot. And what heat is, it heats energy. That's all you can really think about it. It's just a lot of energy. And when you put the balloon right over that heat wants to rise into the balloon. It wants to touch it, right? And because of the material of the balloon and the fact that we only really have air in there, as you try to heat it, the air wants to expand a bit. And when the material of the balloon touches the flame, it explodes because it has too much energy for the balloon to handle. So that's what happened. So let's try something slightly different. And what we're going to do is actually fill it with water. Let's see if we have the same reaction. And I'm going to reflame my candle. As you can see, this balloon right here has plenty of water in it, but I'm going to show you how to make it too. And it might take a few tries to get the right amount of water in. Alright, so let's light our candle. And I'm going to use the white balloon instead of the red balloon so we can see. And when you get a new balloon, they're flat, there's nothing in there, so let's just put a little bit of air in it real quick. Just so there's air. And this is where our funnel comes in, and let's pour a little bit of water in. Alright, I have just a pitcher of water right here, and let's pour it in really, really slowly so you don't, that was stuck, so that you don't get the water to come out, alright? So you would do it just like this, again slowly. And I'm going to put my water over here. Same thing. Let's blow the air up with air now also, so it can expand. Maybe a little bit bigger. And let's do this wonderful knot that I just learned how to do. Alright. Okay, so this is just a close-up for you guys so that you believe me there's a little bit of water in it. It's tough to see if you can see me shaking around the water at the bottom, like this. So what we're going to do is we're going to do the same thing. Let's try to put this over the flame. Let's see if the same thing happens, alright? So I'm going to start really high. Alright, can touch the flame. Look at that. All right, so I got so close to the flame I actually got some of the ash on the balloon. All right, so I don't have water exploded everywhere. I'm clean, and we were successful in having our balloon right over the flame of the candle. All right, so that was pretty neat, and I was able to hold it there enough. As you can see, there's actually the mark from the ash from the fire to prove, in case you didn't see it, it definitely was on it. And you may ask why, we still have air in the balloon. The balloon's still made out of a material that doesn't like fire. Why is it now that there's some water in it that it doesn't expand, it doesn't explode? So the reason why is, I think it's first best to explain from the standpoint of energy. So the heat, the flame, it's a lot of energy. And when we tried to give that to our normal balloon, our regular balloon with air, the balloon didn't know what to do with it. It was made out of just air. That air wanted to expand, heat up, and it exploded. But with a little bit of water, it knew what to do with the energy. So the reason why is that as you heat up water, it is a good conductor of the heat, at least relative right now. And what that means is that it can hold a lot of heat. It knows what to do with that energy. It's not like the balloon that exploded with the balloon and just air. With the water, it knew what to do with the energy. And instead of exploding and causing this big scene, what it did is the water itself was able to heat up without a lot of the air or the balloon itself exploding. So eventually that water, as you would hold it over for a very long time, would get very, very, very hot, but for our sake and purposes, it was able to stand right over the flame.